Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson 6, describing the center of a distribution using the mean. Okay, here we go. Classwork and example 1. Recall that in lesson 3, Robert, a 6th grader at Roosevelt Middle School, investigated the number of hours of sleep 6th grade students get on school nights. Today, he is to make a short report to the class on his investigation. Here is his report. I took a survey of 29 6th graders asking them, how many hours of sleep per night do you usually get when you have school the next day? The first thing I had to do was to organize the data. I did this by drawing a dot plot. Looking at the dot plot, I would say that the typical amount of sleep is 8 or 9 hours. So here's a dot plot, number of hours of sleep. The minimum was 5, maximum was 12, and the mode was 9, and 8 was pretty close to the mode, only 1 off. Okay, so Michelle is Robert's classmate. She likes his report, but has a really different thought about determining the center of the number of hours of sleep. Her idea is to even out the data in order to determine a typical center value. Exercise 1. Suppose that Michelle asks 10 of her classmates for the number of hours they usually sleep when there is school the next day. Suppose they responded in hours, 8, 10, 8, 8, 11, 11, 9, 8, 10, and 7. How do you think Robert would organize this new data? What do you think Robert would say is the center of these 10 data points and why? Okay, Robert would use a dot plot to organize his data and would say the center is around 8 hours because it is the most common value. Okay, so there's number 1. Okay, page 2, number 2 says, do you think his value is a good measure to use for the center of Michelle's data set? Why or why not? Okay, and the reason here, the answers would vary. Different students might have different outlook on this, but here's an example. Students might say it is a good measure as most of the values are around 8 hours. Or they might say it is not a good measure because half of the values are greater than 8 hours. All right, so that's that. So then let's move on to the measure of center that Michelle is proposing is called the mean. She finds the total number of hours of sleep for the 10 students, that is 90 hours. So she added all of those values up and got 90. She has 90 Unifix cubes, snap cubes. She gives each of the 10 students the number of cubes that equals the number of hours for sleep each had reported. She then asks each of the 10 students to connect their cubes in a stack and put their stacks on a table to compare them. She then has them share their cubes with each other until they all have the same number of cubes in their stacks when they are done sharing. That's called socialism. Number 3, make 10 stacks of cubes representing the number of hours of sleep for each of the 10 students. Using Michelle's method, how many cubes are in each of the 10 stacks when they're done sharing? Okay, so here are the Unifix cubes. And I copied the number over. These are the results that she got for sleep hours. So 8, 10, 8. So this is 1, 2, 3, 4, 5, 6, 7, 8. This one's 10, 8, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need 2 more of those. So I'll put 1 here. There's 11. I'll put 1 more here. There's 11. So those are those 2 11s. Here's 9. Here's 8. Here's 10. And here's 7. Okay, so it says make 10 stacks of cubes representing the number of hours of sleep for each of the 10 students, which is right here. Using Michelle's method, how many cubes are in each of the 10 stacks when they are done sharing? So what you want to do is you want to take the tallest stack, 11, and take one away and fill the shortest stack. So that one's done. So now everybody has at least 8. Take that 11 and start the next row. Now that's 8 is 9. this 10 will become 9 when it gives an 8, 1. So there's 9. And if I move this one over to here and move this one over to here and then move this one over to here, we now have 10 stacks of 9 cubes. So how many cubes are in each of the 10 stacks when they are done sharing? And the answer is 9. 9 cubes. Okay, so that's number 3. Okay, number 4 says, noting that each cube represents 1 hour of sleep, interpret your answer to exercise 3 in terms of number of hours of sleep. What does this number of cubes in each stack represent, and what is the value called? Okay, so if all 10 students slept the same number of hours, it would be 9 hours. The 9 cubes from each stack represent the 9 hours of sleep for each student if this was a fair share. This value is called the mean. Okay, number 5 says, suppose that the student who told Michelle he slept 7 hours. So that's this pile right here. This has 7 in it. Maybe his data value has changed to 8 hours. So I need to add 1 to his pile. So now he has 8. Okay, so that's what that's going to look like now. What does Michelle's procedure now produce for her center of the new set of data? So in other words, what would be the average? So again, we would take these cubes and share them evenly and come up with an average. So then we have this here, move this over here, and move this over here. Well, we have 1 more cube left. So the only way we can evenly distribute a cube would be to cut it into pieces. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 piles. So I'd have to cut this into tenths. So every pile would have, this is 9, but then I would have to add a tenth to it. So 9 and 1/10 in every pile. So I need a tenth of a cube so that everybody had the exact same number. So that would represent a portion of an hour. Okay, so the extra cube must be split into 10 equal parts. The mean is now 9 and 1/10 of an hour. Well, 1/10 of an hour, what's 1/10 of 60? Well, it's 6. So that'd be 9 hours and 6 minutes per sleeping student. Okay, number 6 says to interpret Michelle's fair share procedure by developing a mathematical formula that results in finding the fair share value without actually using cubes. Be sure that you can explain clearly how the fair share procedure and the mathematical formula relate to each other. Okay, so answers may vary here. And the fair share procedure is the same as adding all of the data values and dividing by the total number of data values. Okay, so add them all up and divide by the number of values. Okay, page 3 brings us to example 2. And it says, suppose that Robert asked 5 6th graders how many pets each had. Their responses were 2, 6, 2, 4, and 1. Robert showed the data with cubes as follows. So he's going from least to greatest. So this is the 1 and 2 students had 2, 1 had 4, and 1 had 6. So it says, note that 1 student has 1 pet, 2 students have 2 pets each, 1 student has 4 pets, and 1 student has 6 pets. Robert also represented the data set in the following dot plot. So then he plotted these 1, 2, no one had 3, 1, 4, no one had 5, and 1 had 6. Robert wants to illustrate Michelle's fair share method by using dot plots. He drew the following dot plot and said that it represents the result of the students with 6 pets sharing 1 of her pets with the student who has 1 pet. Okay, so here's the dot plot with number of pets. Okay, what happened here? This dot that's at 6 moved over to 5. So that means they took 1 pet from the person who had 6 and now they only have 5. So nobody has 6 pets anymore. And 1 pet that was taken from the one who had 6 was given to the person who only had one pet. So now they have two pets, so their dot moved to 2. Okay, so that moved the 6 down to 5 and the 1 up to 2. Okay, so there's the diagram of that. Okay, now here's page 4. It says Robert also represented the dot plot above with these cubes. So here's the cubes. So he's already taken the one who had 6, given it to the one who had 1. So now we're at 2, 2, 2, 4, 5. All right, so there's his representation shown. Now on exercises 7 through 10, it says continue distributing the pets based on the following steps. 7, Robert does a fair share step by having the student with 5 pets share one of her pets with one of the students with 2 pets. So that's going to move this over here. Draw the cube's representation that shows the result of this fair share step. So this is what you should have now. You should have 4, 4, 2, 2, 3. And actually I'm going to put it here. So we're going in least to greatest order. So it should look like this: 2, 2, 3, 4, 4. Okay, so that's A. So let me do that. Okay, so there's that representation copied down. Now it says draw the dot plot that shows the result of this fair share step. Okay, so now we're going to do a dot plot. So let me go back and I'll just copy this. Okay, so I'm just going to draw these dots in. So here is the dot plot, number of pets. Nobody has 1 anymore. We have 2 students who have 2, so I'll put a dot here and a dot here. There's 2 students who have 2. 1 has 3 and 2 have 4. So the dot plot, notice what's happening here. We had a 1, we had 2 2s, we had a 4 and a 6. The 6 moved to 5 going to the 1, and the 1 that came from 6 came to 2, making this here. We had 3 0 1 1. And now we have 2 3 2. Okay. Now 8 says Robert does another fair share step by having one of the students who has 4 pets share with one of the students who has 2 pets. Draw the cube's representation that shows the result of this fair share step. So what's going to happen here is I'm going to take 4 from, go back up to my original here, take one of the 4 and give it to one of the 2, and I'll put it here so that it's increasing in numbers. So now we have 4 3 3 3 2. So this is what that would look like. Okay, so here's the cube representation: 2 3 3 3 4. Okay, so now page 5 says part B, draw the dot plot that shows the results of this fair share step. So I copied this over, and now we need to make a dot plot of that. Okay, so here we go. What are we going to put on this dot plot? Well, we have 1 student now with 2 pets, and only 1 student has 2 pets. We have 3 students with 3 pets, and we have 1 student with 4. And there's our dot plot. Okay, number 9 says Robert does a final fair share step by having the student who has 4 pets share 1 pet with the student who has 2 pets. Draw the cube representation that shows the result of this final fair share step. Okay, so here's what I'm going to do. I'm going to take the 1 from the 4 and I'm going to bring it over to the 3. So now we have 3 3 3 3 3, where it was 5 4 2 2 2. Okay, so there's part A. That's what it would look like drawn. And now we're going to do a dot plot. Draw a dot plot representing what the results are. So we have 1 2 3 4 5 people, 5 students who all have 3 pets now. Okay, so you'd have 5 dots at 3. Now it says explain in your own words why the final representations using cubes and a dot plot show that the mean number of pets owned by the 5 students was 3. Okay, so here's an example of an answer. The sharing method produces 3 pets for each of the 5 students. The cube's representation shows that after sharing, each student has a fair share of 3 pets. The dot plot representation should have all of the data points at the same point on the number line, the mean. In this problem, the mean number of pets is 3 for these 5 students. So there should be 5 dots above 3 on the horizontal scale. Okay, page 6 brings us to the end of lesson 6. Go to your problem set.